Yeah, hi everyone. Good evening and welcome to Cat Ninjas. Good evening to all of you. Trust everybody is doing good. Good evening and welcome. Good evening and welcome all of you. Welcome all of you and good evening. Trust everybody is doing good out here. Good evening. Good evening. Can respond in the comments quickly in the chat that I'm clearly audible to you. We are good to start. Yeah. All right. Great. So here we are. So we'll continue our a little bit of study on So we'll study about the probability. We'll continue our discussion on it. So before we kind of start on that, we will uh, okay, all right, so let's get started. Before we start, let me quickly introduce myself. I am Belvi Srinivas. I've been working in the test prep industry for the last 14 years, 15 years. That's since 2007, and I worked in various capacities, both in terms of management as well as in terms of training. And yes, so during those 14 years, I developed some good skill to train the students in the space of QA, DI, and LR. That's briefly about me. And if you'd like to have short discussions, the brief counselings, or your doubts to be resolved, you can join this particular Telegram channel. On this channel, you can take up the short discussions on it. Yeah, that's quickly how you can interface with me. So before I start, let me make quick announcements. So these are the new batches that are starting on the Plus platform. So on 20th October, that's yesterday, there is a batch which started for technically CAT 22 and OMET 22. If you are looking at, or if anybody knows that you are there preparing for CAT 22, that's a recommended batch. Yeah, hi, good evening, Rishabh. Good evening, Shashank. Good evening. Yeah, good evening, Vibha. Right, on 23rd, that's 2 days from now. From 23rd onwards, there are batches starting for CAT and OMET 22, and there is a batch starting for SNAP 21. These are the plus batches, which means these are the structured courses taken by some of these wonderful educators. So these are the structured batches. Now, if you would like to take up those structured courses, be it on SNAP, be it on IIFT, be it on CAT, or whichever the revision batches, etc., in a very structured fashion. So you might have to look for the subscription, and 6 months plus subscription would cost about 16,000. And if you use any of the educator code, including my code, you get a 10% discount on the mentioned prices. But there are other packages as well. You can take a look. If you are trying to make a buy, you can take a look and you can use the educator code. If you are looking at one-to-one interactions as well, handful of one-to-one interactions with the mentors of your choice, so you can set up the meeting and you can have those discussions. Then you may have to go for the iconic subscription, because of the plus you will not have the facility to set up those short meetings and have those discussions can be with regard to any of this. It can be with your preparation plan, it can be your interview questions, or it could be with respect to the study plan or test improvement. How do we test analysis? Any of this you can kind of, so you want to set up those meetings, you may have to go for the iconic subscription. That's briefly about the plans that are available, and on all these plans you will get 10% discount whenever you use any of the educator code, including my code. You get 10% discount on any of these plans that we are talking about. And if you want further discount more than that, please take this CAT combat test, which happens on Sunday, that is on 24th at 5 p.m. It's just about a 60-minute test with sample 30 questions. It's not very difficult to score here. I'm sure some of you would have already taken these kind of tests out here, and you can avail the scholarship. The top 3 rankers will get 1 year fee subscription, 75% scholarship, 50% scholarship, 25% scholarship. So in addition to that, use the educator code, you will get another 10% on it. So therefore you don't have to really pay anything. You can kind of take the structured courses at absolutely not paying much, right? That's another option. Another option is take this combat, so you can use the educator code to take this particular test. Yeah, that's pretty much about the announcements. So let's unleash ourselves into the lecture. Before we get into the lecture, may I quickly know who are all into the meeting now? So how many of you joined in? Who is there? Nazia joined in. Meanwhile, Asim joined in. Sumit has joined in. Good evening, guys. Good evening. Who else? Who else? Other than the names that I'm reading, anybody else active in the meeting? You can put it in the live chat. so that helps me to understand who are active in the chat, who are active in the meeting. I mean, active in the lecture. Yeah, you can exchange your greetings. Mayank, anybody can give cat. What is the problem? Yeah. All right. Srishti has joined. Good evening, guys. All right. Good, great. All right. So here we go. So as usual, before we get into the conditional probability, we'll start with Kishan has also joined in. Very nice, guys. Very nice. Super. Yeah. So we'll start with one of the teaser kind of questions, because generally we did most of it on the unbiased side. What if it gets biased? What happens if the things get biased, right? So you go to the clubs, etc. Sometimes things are biased, right? So this is one of the biased dice here. So how do we go about solving this particular question? All of you reflect about this particular question, maybe for a minute, think about it. I'm sure you would have. So there are biased studies and unbiased studies. I'm just pulling up just to illustrate that, hey, don't think that every time the questions are going to be unbiased. Sometimes it can be biased. So if it is biased, how we are going to approach this? Take a quick look at this particular question. I will not spend too much time on biased. It's simple, because it's simple. With this question, you will understand it. Yeah, spend a minute, think about it. How do you approach a biased question? Coins can be biased, dice can be biased, games can be biased. Okay, good. All right. Now listen to me. That's a good reflection time. What do we know? What do we know is this. Technically, if it is not a biased dice, because this is biased. Why it is biased? The probability of getting an even number when a dice is rolled, probability of getting an even number is thrice. All right. It is thrice the probability of getting an odd number. Technically, what? If it is unbiased dice, it is unbiased. If it is unbiased dice, what do you expect? Probability of getting 1 should be 1 by 6. Probability of getting 2 should also be 1 by 6. Probability of getting 3 should also be 1 by 6. Be it odd number or even number, they all should be 1 by 6, because it is unbiased, right? It has to be unbiased. So probability of getting 6 is also 1 by 6. What is the total probability? Therefore, what is total probability of total? Any of this put together, total probability is 1, right? Yeah. Now I'll just change the definition. What I'll say is it is the same thing. Instead of unbiased, what if I make it biased? That is what the author is asking about. Hey, what if it is biased? What if it is biased? The total probability does not change. That is the beautiful thing about it. The total probability, okay, let me write on this particular side. What if it is biased? If it is biased, the total probability still remains 1. Total probability never changes. It is 100%. There is nothing called as 120%, 130%. No, it is 100% only. Total probability is 1. Certain event, all right, total probability is 1. Because when you roll a biased dice also, either you will get 1 as the outcome, or 2 as the outcome, or 3 as the outcome, 4, 5 or 6. These are the outcomes. It may be biased, but your outcomes are not going to change. It has to be 1, 2, 3, 4, 5, 6 only. Therefore, it is total probability is going to be 1. Okay, what author is trying to say is, hey, if the probability of getting 1 is x, then the probability of getting 2 is 3x. That is what he's trying to say. Read this statement once again. The probability of getting an even number. Even number means what? 2, 4 or 6. The probability of getting an even number is 3 times, right? It is into 3. 3 times the probability of getting an odd number. Odd number means what? 1, 3 or 5. If I say that the probability of getting an odd number, that is 1, is x, it's an assumption. If the probability of getting 1 is x, then the probability of getting 2 becomes 3x. It should be thrice. Therefore, it should become 3x, right? Yeah, guys, x and 3x are clear. It's a number. I don't know what is that x. If the probability of getting 1 is x, then the probability of getting 2 is 3x. That much I know. That is the meaning of this underlined, green color underlined statement. Is that statement clear to you? total probability is 1 and the probability of getting 1 is 3, 1 is x, then the probability of getting 2 is 3x. Is that clear? So far it is clear. That much is clear, because that's the starting point, which means when this question is presented, you write total probability as 1 and you would have started writing x and 3x. This is what you would have done. That's the starting point. Yeah, then it remains, the story remains. All right, yeah. So how many of you, all of you are clear? Rishav is clear, Kishan is clear, Sumit is clear, Yogi is clear, Vibha is clear. I'm hoping that others are also clear. Okay, yeah, therefore 3x is x, 3 is x, 4 is 3x, 5 is x, and 6 is 3x. Okay, so therefore these are the numbers here, therefore I will add them. What do you mean by the total probability? Add them. X plus 3x, 4x, all right, again another 4x, another 4x. You are trying to say that, man, this total has become 12x. 12x is equal to 1. Pay attention to this box. 12x is equal to 1. Hey, why 12x? Because you have to add all of this like this. 1 by 6, 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 1 by 6 is equal to 1. It should be equal to 1. There is no choice in the matter. If you add all of this, it should be equal to 1. But I knew very clearly right from my childhood days, which means from the high school, that probability of 1 is 1 by 6, probability of 2 is 1 by 6, if it is unbiased. If it is biased, I don't know, therefore I wrote it as x and I wrote it as 3x. But what I should do, I should add all these fellows. When I added all these fellows, it has become 12x. 12x is equal to 1. Now you are trying to claim that 12x is equal to 1, therefore x is equal to 1 by 12. All right, I will come back and write it. So what I got to know is probability of getting 1 is 1 by 12. Probability of getting 2 therefore is 3 divided by 12, 3x. You can simplify this and write it as 1 by 4 also, I don't mind, but it is technically 3 by 12. What is probability of getting 3? Therefore 1 by 12, because you know that the value of x is 3 by 12, and hence I got these particular numbers. So you get to understand that, okay, because it is biased, it is not that probability of getting 1 is 1 by 6, 2 also becomes 1 by 6. Instead, I will find my numbers for biased. Probability of getting 1 becomes 1 by 12, whereas probability of getting 2 becomes 3 by 12, and so on. Same numbers repeat. 1 by 12s and 3 by 12s keep repeating. I'll be ready with the probability of the numbers. Then I will come to the question after this. Okay, guys, are you clear now? Are you clear now? Probability of getting 1 is 1 by 12, whereas probability of getting 2 becomes 3 by 12, etc. You got these numbers? If it is unbiased, they are all 1 by 6, 1 by 6, 1 by 6. Since it is biased, it will change. It will change because it is biased. Because it is biased. Clear? Everybody clear? Give a quick confirmation. All clear so far? Yeah. Right, good. This is how you work. Beat dice, beat coin, doesn't matter. This is how you kind of work on the bias. So bottom line is what? Total probability is 1. That is the bottom line. The bottom line is total probability is 1. Consider total probability 1 and start working. Now rest is a very mundane job. Now it says that find the probability of getting a sum of outcomes as 6 when dice is rolled thrice. Which means first time, what is the outcome when you rolled first time? When you rolled second time, what is the outcome? All right, when you rolled first time, what is the outcome? When you rolled second time, what is the outcome? When you rolled third time, what is the outcome? Together it should be 6. Let me assume, for instance, let me assume that R1 is always better than or equal to R2, which in turn is always better than or equal to R3. Why? Because permutations are possible. I don't want to permute and write all the cases. I would rather say that R1, first outcome, is always better than the second, which in turn is better than the third, either greater than or equal to. Then I would start saying that the best outcome possible on the first dice is 4. Hey, why? You may say that, why sir, 6 is there, why don't you write 6 here? Hey, I cannot write 6 here because I can't get 2 zeros after that, right? I have best outcome I write on the first dice, first roll has to be 4. That's the best. You can't expect a best because sum has already become 6. So therefore you wouldn't have got more than 4 in the first roll. 4 and 5 and 6. This can be one case. I will say this is one case. Okay. What can be the second case on this? The second case, it can be possible that, hey, this is 3 here, this is 2 here, and this is 1 here. That can be the second case. What can be the third case? The third case can be this is 2 here, this is 2 here, and this is 2 here, which means 2, 2, and 2. These are the only 3 cases possible. However, the first case can be permuted in 3 ways. The first case can be permuted in 3 ways. Why? Because you are saying that in the first roll he got it as 4, but you may disagree. You may also say that no sir, 4 he got here and he got ones and ones here. Correct? Possible. All right, correct, that is possible. But you may say that 4 I got it here and 1 I got it here. That is also possible. Therefore, the first case can be permuted in 3 ways. Second case can be permuted in 3 ways. Third case can also be permuted. Second case can be permuted in 6 ways. Third case, there is only 1 way. Okay, now I have to write the numbers below this. Okay, if you would have got 4, what is the probability of getting a 4? Probability of getting a 4 is 3 by 12. Probability of getting a 4 is 3 by 12. What is probability of getting 1? Probability of getting 1 is 1 by 12. Probability of getting 1 is 1 by 12. What is probability of getting 1? This is also 1 by 12. Therefore, you say that 3 times of 3 ways means what? What is the answer for the first case? Answer for the first case will be 3 times of 3 by 12 into 1 by 12 into 1 by 12. That is how you would have written for the first case. This would become the answer for the first case of getting the result as 6. Okay, are you all with me on the first case? Are you all with me on the first case? Is this clear, crystal clear? Are you all with me on this first case? Clear about this? Is this clear? Probability of getting 4, probability of getting 1 and probability of getting 1. First get the 6 and then write their probabilities. First get the 6 and then write their probabilities. Rishabh, is this clear what I am talking? Yeah, good. Good guys, good. Everybody's following. The one good thing I like about you guys is I say once and you get it. Yeah, that doesn't mean that you should not ask for a doubt. You can. It's not about that. Yeah. So I say once and you get it. That's good. Yeah. What is that, Rishabh, you are trying to say? I thought we could directly do 2 odd and 1 even. 2 odd and 1 even. No. Then it might not cover all your cases, right? It might not cover all your cases. All 3 even is also possible, right? Okay. So there are multiple ways of dealing with this. Fair enough. All right, let's go in here. So here you say that, hey, this particular case is probably 3. This is 6 times of. Why 6 times? Because this can be permuted in 6 ways. Right, 6 ways. Therefore, 6 times of probability of getting a 3. We know the values there. Odd number is 1 by 12. Even number is 3 by 12. And the odd number is 1 by 12. Writing is not a problem from here. You should be able to conclude this. This is 1 time of. So you would say 3 by 12 whole cube. 3 by 12 whole cube. You got to consider the first case. You got to consider the first case, add the second case and also add the third case. You got to get this result. Denominator is 12 cube all the time. Just your numerators keep changing. Denominator remains 12 cube and this becomes your answer. Okay, is this clear to you? Everybody clear on this particular question, how to deal with the biased ones? Biased ones, you got to find out the probability. That's it. I can create the similar kind of questions on coins also. I may say that the probability of getting head is more than probability of getting a tail and I will get a relationship. Once I get a relationship, probability of getting head is not half, probability of getting a tail need not be half, it can be some different number. So once you know that total probability is the key in these kind of questions, what is the key? Total probability remains 1. It is always 100%. It can't be more, it can't be less. Since that remains constant, just imagine something like x, 2x, 3x, whatever you want, you can kind of assign them and you can proceed. Yeah, okay, all right, okay. Ayush, no counseling, my friend here. Already you are asking that, sir, should we take a drop for IPMAT? Okay, no counseling. So these kind of questions require a lot of time to answer. Without knowing you, I cannot answer that why you should take a drop, why you should not take a drop. All these are very subjective questions. Will not do counseling during the class. Counseling can be done after the class offline. Okay, yeah. Come into the Telegram group. Already, then I will ask for your profile, etc. You send it. So let me go through that and then I will find a time and I will connect with you. That's how we'll do that part. Okay, so no quick answers in the chat. You put something in the chat and I will quickly throw my opinion as if I am a god and I know your profile. No, all such things are not going to happen, right? Yeah, let's not be foolish like that. Yeah, and such questions you should not ask on these kind of platforms because these are the life determining questions. How can you simply ask a question and I will tell something and you agree with it, right? It will not make sense. Life is not decided like that and you should not. Okay, you should not ask such questions. Not only here in my lecture, don't ask anybody such questions. Ask them to make time and then let's create that. Okay, good. All right, friends, fair enough. Good, let's go in here. Very popular question. Why don't you answer this? This is a cat question. Cat question asked in the permutation sense. I will come to the cat question after a while. Yeah, so why don't you answer this question? All of you, take a minute. Very favorite question, beautiful question. Answer this. I expect the answer here in the chat. Without simplification also you put the numbers. I'm fine with it. With simplification, without simplification, whichever way. Guys, what happened? Is the chart active? Are you solving? Are you watching? First confirm that. Are you all sitting with a book and a pen here? You guys are sounding very unusual today. Is it any special day that you are not sitting with any book and pen? Can you confirm me? Are you having a book, pen? Are you sitting upright, trying to exercise your mind? What's happening? Confirm, everybody confirm. Are you sitting with a book and pen? Yes, no. Answer this question. Everyone, not just Sumit and Rishabh. Guys, forget answering this question. Answer my question. Are you sitting with a book and a pen? First answer that. Let me have a clarification on that first. Okay, okay. Right, yeah, that's good. Yeah, first do that. Okay, so all right. Anyway, let me explain this. I give some time. Let me explain this. Let me draw a 4 by 4 square. Right, let me draw a 4 by 4 square. Let me just draw a 4 by 4 square, illustrate, because this chessboard is too big, right? This 8 by 8 square is too big. Let me just draw 4 by 4 square to illustrate my point, what I'm trying to say here. Good, good. Yeah, good, Raman Preet. I observed. I observed. Everybody's sitting with a book and pen. That's nice. And also stay live. Stay live. Don't try to lag. If you lag, then by the time I receive your response, there will be further lag. Okay, so let's take a look at this. 4 by 4 square. Total number of squares that can be observed. Good, good, Naresh. Good. Yeah, total number of squares that can be observed is not just 4 by 4. Right, it is not just 4 by 4, it is not 16 squares. It is not about, hey, I will count how many columns are there. There is a first column, second column, third column, fourth column, and there is a first row, there is a second row, there is a third row, and there is a fourth row. Therefore you can't say that, hey, there are only 16 squares out here, which need not be right. Now these are unitary squares. How many squares of dimension 1 by 1 can be observed on this grid? That will become 4 by 4, 4 rows and 4 columns, number of rows and number of columns. So you say that, man, this is going to be 16. That is fair enough. How many squares here? This is a dimension. How many squares of dimension 1 by 1 can be observed? You will say 16. If I ask you that, hey, how many squares of dimension 2 by 2 can be observed, then you would say that, hey, there would be 9 such squares. 3 into 3, there would be 9 such squares whose dimension is going to be 2 by 2. Just observe this. Okay, this is 1 2 by 2. Follow the marker here. All right, this is 1 2 by 2. This is 2 by 2 square. This is also 2 by 2 square. I can start here. This becomes another 2 by 2 square. Then I could start here and this becomes another 2 by 2 square. I showed you 3. Likewise, you can count further. I don't have to show everything out there. Okay, if you want me to show something like this, okay, this is the fourth one out here, fourth one out here, fourth, fifth, sixth, seventh, eighth, and ninth. Therefore, you will say that the dimension has to be 2 by 2. It will be 9 in number. Are you getting this point? Are you getting this point? Everyone, are you getting this point? Are you getting this point? I don't have to illustrate completely, but did you get this point? What I'm trying to say? How many squares of dimension 2 by 2? That's going to be 9. Is that clear? Is that clear? You have to talk dimensions. You have to talk dimensions here. You have to talk dimensions. Making sense to everyone? Making sense? Hang on, Rishabh. Hang on. So this is the very popular question. What I'm talking is a very popular question. How to do it? We will come to it. We'll come to it. We just started study. We just started. Hang on. Hang on. Okay, you didn't get that, Asim. What I'm trying to say is, look how many 1 by 1 squares, that is 16, right? 1 by 1 squares are 16. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So now I'm going all over 14, 15, 16. Now these are number of 1 by 1 squares, which means length is 1 unit, breadth is 1 unit. These are number of 1 by 1 squares. Okay, that is 16 in number. Just go to this last number, that is 16 in number. That is 16 in number. Okay, now coming to that, hey, how many 2 by 2 squares are there? That is what I was asking you, right? Next question was length 2 units and breadth 2 units, right? I'm talking about length 2 units and breadth 2 units. So two of you have the doubts here. So length 2 unit, breadth 2 unit. Now see here, if I select shortlist this square, this is a 2 by 2 square. This entire thing is a 2 by 2 square. Could you visualize this? Asim, could you visualize? Could you visualize what I'm trying to say? Could you visualize number of 2 by 2 squares is clear? This, could you visualize this 2 by 2? Kishan, yeah, got that. Yeah, similarly, instead of that, I can also select this 2 by 2 square instead of that. This is another 2 by 2 square, which is different from what I shortlisted earlier. This is another 2 by 2 square. Another 2 by 2 square, right? Similarly, right, I will have third. All right, now this becomes another 2 by 2 square. 3, I already showed you 3 here. Now shift your base to the next level. Consider from this particular level, you get the fourth one. Likewise, all right, likewise. Therefore, what you are saying here is, hey, I will have 3 by 3 in the sense I can shortlist the columns in 3 ways. What is that? Rows in 3 ways. What are the rows you are shortlisting? I will shortlist row 3 by row 4. These two consecutive, one way. Second one is I will shortlist row 2 and row 3, two consecutive shortlist, row 2 and row 3, and I can close this. Or you may say that I can shortlist row 1 and row 2, and I can close this, and I can close this. Now while shortlisting, now listen to this, along with, listen, everybody listen to this very, very carefully, because next question is going to come, the actual CAT question. That is when I want you to perform, right? This is a CAT replica. So next question is going to come wherein you have to perform. For that you have to understand this consecutive selection. Now along with row 1 and row 2, I can select column 2 and column 3. If I select row 1, row 2 with column 2, column 3, this is the square, 2 by 2 square I'm talking about. This is the 2 by 2 square I'm talking about. Now you may say that, okay, sir, along with row 1, row 2, if I select column 2 and column 3, column 3 and column 4, then this is what I'm talking about. Hey, what is that I'm talking? Listen to this shortlisted portion. Row 1 and row 2, intersection of row 1, row 2 with, along with column 3, column 4, column 3 and column 4. If I do this, this hashed region is what you are going to get. This is what you are going to get. This is what you mean by selecting 2 rows and selecting 2 columns. That is the meaning of selecting 2 rows and 2 columns to get a 2 by 2 square. Now listen to this. Hey sir, what if I would have select any 2 consecutive for that matter? Select any 2 consecutive for that matter. If you select row 2 and row 3, you select row 2, row 3, and then intersect this with column 2 and column 3. Intersect this with column 2 and column 3. You get this. Row 2, row 3 intersected with column 2, column 3 means this is the square I am talking about. So therefore, I said that rows can be selected in 3 ways. What do you mean by 3 ways? R1, R2 I can consider, or R2, R3 I can consider, or R3, R2, R1, R2, or R2, R3, or R3, R4. Now these are the 3 ways of considering the 2 consecutive rows. Now there are 3 ways of considering 2 consecutive columns. Column 1, column 2 I can select, column 2, column 3 I can select, column 3, column 4 I can select. Now therefore I said that any combination of this particular combination of rows can be considered with any of the columns, and hence I said that 3 into 3 I will get 9 squares. Is the explanation clear to you? What is this 3 by 3 is clear, my friends? What is this 3 by 3 is clear? Yes or no? Is this clear? How I am writing this 3 by 3 is clear. I was talking rows and columns in my mind. I was talking rows and columns. Quickly confirm. This is a very important concept. Consecutive selections is an important concept. Right? Okay. All right. Good. Yeah, that's the point there. All right, let's come into this. Hey, how many squares of dimension 3 by 3 can be observed here? 3 by 3 can be observed means row 1, row 2, row 3, and then row 2, row 3, row 4. Two ways. Rows can be considered in two ways. I've showed it there. Columns can be considered in two ways. Therefore, there will be 4 squares. Hey, how many squares of dimension 4 by 4 can be observed? If you want 4 by 4 square, you got to consider all 4 columns at once. Therefore, you say that 1 into 1, there can be only 1 here, and hence you say the total number of squares that can be observed is summation 1 square. This is summation 1 square, 2 square, 3 square, and 4 square. I just have to add up these particular numbers. Summation 1 square, 2 square. Here you can add manually. If it is a bigger grid, since it was a chessboard 8 by 8, instead of doing it manually, you would have written it as summation n square, because if it is a square configuration, because it was a 4 by 4 square what I took as a dummy, since you have a 8 by 8 square, you also get this pattern. Therefore, I said it's one of the popular questions. Since you are getting 8 by 8, you kind of remember that the total number of squares that can be observed in a square matrix is summation n square. So in this particular case, you would have calculated summation 8 square. That will be the total number of squares. Is that clear to you? Bottom is clear to you, base is clear. Your base for this answer is summation 8 square. Is that clear to you? Total number of squares that can be observed on the chessboard is summation 8 square. Going by the same logic, whatever I've showed on 4 by 4 board, same thing will be observed on 8 by 8 board as well. Summation 8 square is clear. We all know how to find that. 8 into 9 into 17 divided by 6. We'll get some number, which would be 204. Which would be 204. That you get it anyway. Guys, other than Rishabh, did you understand what I'm saying here? The denominator is clear. Denominator is clear. Yeah. Right. Okay. Now look at the numerator. Now listen to me. Everybody listen to me. Look at the numerator here. So numerator, consecutive selections. Listen to me. Consecutive selection of R things. Consecutive selection of R things. Consecutive selection of R things out of N things. Out of N things in the linear fashion. Out of N things in a linear fashion. Consecutive selection of R things, listen to this very carefully, R things out of N things kept in a linear fashion is given by N minus R plus 1. Is given by N minus R plus 1. Consecutive selection of R things out of N things. Selection. It is a what? Consecutive what? I am omitting this word. Consecutive selection. Don't write NCR. Hey, selection of R things out of N things is NCR. This is randomly any R things. It is not consecutive R things. But I am looking at consecutive things. R consecutive things. Selection of R consecutive things out of N things is N things kept in a linear fashion is given by N minus R plus 1. Let me quickly illustrate. Assume that these students, these are the badge student numbers. So these 5, 6 students are standing in a row. All right, now 7, 8 students. These 8 fellows are standing in a row. I said that, hey, why don't you pick 3 students, 3 adjacent students, 3 students, 3 consecutive selections out of these 8 students. They're just standing in a row. Their badge numbers are 1, 2, 3, 4, 5, 6, 7, 8. I'm saying that why don't you pick 3 fellows? All right, 3 fellows, all right, now who are next to each other. That's nothing but consecutive selection of 3 things. You may say that, sir, I will do this. This is one selection. Second selection, you can start from 2, go up to 4. Third selection, 3 to 5. Fourth selection, 4 to 6. Next selection, 6 to 8. That's it. So therefore, these are the 5 selections you are talking about. 1, this is the second one, third one, fourth one, fifth one. Can also be written as my n is equal to 8. There were n things kept in the linear fashion. I wanted 3 consecutive things given by 8 minus 3 plus 1. Out of 8 things, or did I miss out anything here? Yeah, out of 8 things, I want 3 consecutive things. 8 minus 3 plus 1, there should be 6 selections. I think I made one mistake there. So you start from 5, go up to 7, then go start from 6, go up to 8. These are the 6 selections there. Did you get this point? Is this definition clear? N minus R plus 1. This box is clear. This box is clear. Selection of R consecutive things out of N things is given by N minus R plus 1. Is this clear? Is this clear? Selection of R consecutive things out of N things is given by N minus R plus 1. Right. Okay. Yeah. Okay, now come to this. Now let me apply that on this. Now let me apply this on this. Let me apply. Okay, so now when I look at the chessboard, I will have how many rows? 8 rows. I look at the chessboard in your mind. Take a chessboard in your mind. R1, R2, R3 like this. You have R8, right? 8 rows are there. Similarly, 8 columns are there. Column 1, column 2, column 3 like this. Column 8 are there. Now, if you want to form a 5 by 5 square, what you want? You want 5 consecutive rows. You want 5 consecutive rows and you want 5 consecutive columns. It should be consecutive. You can't select one box there, one box somewhere. You got to select 5 consecutive rows and 5 consecutive columns. Fair enough. How many rows I have? 8 rows I have. I want how many out of this? 5 I want. Therefore, you write that out of 8 I want 5, n minus r plus 1. These many ways I can select the rows and the columns. This is the number of ways of selecting the rows. Number of ways of selecting the columns is also 8 minus 5 plus 1. This is the number of ways of selecting the columns. Therefore, you say that, hey, this is nothing but there are 4 ways to select the rows and 4 ways to select the column. Therefore, 16 ways you can decide the 5 by 5 square divided by 204, which becomes your answer for this question. Everyone clear with the concept? I am not just looking at this question. You are clear with the concept of consecutive selections playing a role here? The consecutive selections playing a role here. That is the concept I am talking here. The role of consecutive selection is the concept I am discussing here. Understood? Everybody understood? Everybody understood? Quickly confirm. Everybody confirm. Yeah. Good. Very good. Now try this question. Now CAT question was in fact little harder than this. It was little harder than this. This is actually a little easier than CAT question, but you will be able to do. Once you do this question, you will be able to do the next one. The CAT one you will be able to answer. That's not a problem. So just do this question. That gives a confirmation that okay, we are on top of it. Find the number of rectangles of area 12 centimeters square that can be observed in the following diagram, given that each grid is 1 centimeter. Each one is 1 centimeter. So if you just want to understand, each grid is 1 centimeter. I want the rectangles of area 12. The figure should be clearly available. Count the rows, count the columns, and do the due diligence. I will give 2 minutes. Think about this and give me the count. Think about this and give me the count. If you want a little more time, I will give the time. But give me the answer. Number of rectangles of area 12 centimeters square that can be observed on this particular diagram. Number of rows need not be equal to number of columns. Check this diagram, count it, take time and answer this. No, Nazia, that is not the answer. That is any rectangle. But I have an area for the rectangle. It should be 12. What you gave me is total number of rectangles, which does not matter. That's not the answer. CAT didn't ask that question. That is total number of rectangles, which everybody will do. CAT won't ask that question. Good. I think some of you may be thinking, I will extend the time. I will extend. I will extend by another minute. Think and put the answer. Put the answer. Verify your answers and put the answers. We will see, Preet. We will see. We will see what is right, what is wrong. You verify what you have written. Okay, good. Everybody's thinking. That's nice. That's nice. Good. I have another 30 seconds to think. This consecutive selection is one of the very important concepts. Okay, good. All right. All right. Let's see. Let's go ahead. Let's see. Okay, so we want 12. Say how many rows I have. I have 1, 2, 3, 4, 5, and 6. I have 6 rows. How many columns do I have? Column 1, column 2, column 3, column 4, column 5, column 6, 7, and 8. I have 8 columns and 6 rows. That is what I have the grid size, which means the row wise, all right, now this is 6 units, this is 6 units, and this is 8 units because each one of them is 1 centimeter. Therefore, 8 centimeter by 6 centimeters. That is the total area on this particular grid, which is not important anyway because we are looking at the counting part. Okay. Firstly, 12 centimeters length into breadth should be equal to 12. So because the area has to be 12 centimeters square, length into breadth is 12. One way of writing is length can be 12, breadth can be 1, which becomes 12. That is one case. All right. Case 2, the length can be 6 and breadth can be 2. That is another case. I'm just saying that okay, all these things will just flash in your mind and some of them will have their natural death. They will die out. What will die out? This case would have died out because you understand that, man, 12 into 1, how is it possible? I don't have neither 12 rows nor I have 12 columns. That's nowhere it is possible. That will die its natural death. But these are the things which flash in your mind. So that's what I'm saying. Case 3, you may say that, hey, I can have 4 into 3. So now these are the 3 cases, out of which the first case does not come into the picture. That is ruled out. Case 2 and case 3 is what comes into the picture. Okay, now let me take the case 2 to start with. Let me take the case 2. Case 2, you are saying that 6 by 2 is equal to 12, which means I can select 6 on one side, 2 on the other side, and I can do that. For example, I can select these 6 rows. I can select these 6 rows and I can select these 2 columns. This becomes my rectangle. Is the area of this rectangle 12 square units? Why not? This is 12 square unit. That is quite possible there. All right, that is one way. So, but then point is, why I should select column 1, column 2 along with the first 6 rows? I can select column 2, column 3 also. Therefore, it should be consecutive selection. Column 1, column 2 you should select, or column 2, column 3 you should select. It must be a consecutive selection. Fair enough. Therefore, you understood the consecutive selection. Rows can be selected only in one way because all say this is rows. I'm giving this to the rows. I'm giving this to the columns. These rows can be selected only in one way. However, the columns can be selected in 8 minus 2 plus 1, which can be selected in 7 ways. 1 into 7. Therefore, you are saying that 7 ways. 6 by 2 can be selected in 7 ways. Now there is another alternative. What did you say? You said that I will select 6. Now I will select the dimension of 6 along the rows and I will select the dimension of 2 along the columns. It can be other way around. I would say that, man, you better select now 6 along the columns and then you better select these 2 along the rows, which means what I'm trying to talk is this. Listen to this. I'm talking this. Hey, why not select like this? 6 along the columns, 6 along the columns and 2 along the rows. This is also 12. This is also 12. The shape looks different. Okay, in that case, what you are trying to do, okay, I want 6 units along the column, 6 consecutive units. So you can select this in 8 minus 6 plus 1. 8 minus 6 plus 1 along the rows. Along the rows, I have 6 units. I want any 2 units. Therefore, you say that, hey, 6 minus 2 plus 1. And hence you are saying that, hey, this is nothing but 3 into 5. You are saying that I can get 15 such triangles, such rectangles out there. 7 plus 15, all right, 7 plus 15, which is nothing but 22. You are trying to say that case 2 answer is 22. Case 2, I will get 22 rectangles, or 22 rectangles whose area is 12 square unit, but they are of the configuration 6 by 2. Understood, my friends? 6 by 2 configuration is clear to all of you. Is this number 22 clear? Is this 6 by 2 configuration clear? 6 by 2 configuration, you will have 22 cases. Did you get this? Did you understand this? First, give me that confirmation. Some of you got the right answer, wrong answer, all that is later. First, tell that, okay, this is clear to us. Okay. I hope everybody is clear on this, right? Okay. All right. Let's go to case 3. Let's go to case 3. Case 3 is 4 by 3. Now I'm looking at the 4 by 3 matrix, right? This 4 by 3. I'm writing it here itself. 4 by 3. 4 corresponds to rows. I'm doing it here itself. Say 4 corresponds to row and 3 corresponds to column. 4 corresponds to row, 3 corresponds to column implies like this. 4 along the row and 3 along the column. This can be one of the figures. This can be one of the figures. But you want 4 rows. 4 rows can be selected in 6 minus 4 plus 1 ways. Now 3 columns can be selected in 8 columns are there. 8 minus 3 because you want 3 at a time plus 1. So this results in 3 into 6. 3 into 6, you are saying that 18 cases. Fair enough. On one hand, I have 18 cases. On the other hand, why this 4 be on the rows? This 4 can be on the columns and this 3 can be on the rows as well. It is possible that this can be on the rows as well. Okay, coming to this columns part. So now 4 along the columns. How many columns I have? 8. Therefore, 8 minus 4 plus 1. Row wise, I have 6 rows, but I want 3 at a time. 6 minus 3 plus 1. 3 consecutive. So therefore, you are writing it like this: 8 minus 4 plus 1, which is 5. 6 minus I hope you are getting this. 6 minus 3 plus 1, all at which is nothing but 4. 6 into 4 becomes 20. Therefore, you are saying that the result on this particular side is nothing but 38. Coming back to this, you would come back and represent this as, oh, there are 38 such rectangles possible. Together, case 2 plus case 3 put together, 60 such rectangles are possible, which becomes my answer. Everyone is crystal clear about this? Everybody is crystal clear about this? Yeah, handful of you gave the right answer. That's good. It takes some time to answer this question, no doubt. But this was the CAT question. This is what they ask. They will never ask what is the total number of rectangles. Total number of rectangles is a cakewalk that everybody will do. They will ask us to think a little bit. That's what CAT does. Okay, everyone did this. Everyone got this. Everyone got this. Let's go further. Let's go further. All right, take a look at this. This is the conditional probability. This is the conditional probability. What is the conditional probability? A part of outcome would have been given. All right, that is called as the conditional probability. A part of outcome will be given. It is very important, friends. You also study this under school from conditional probability. Some of you would have written this as Bayes theorem also. Conditional probability or Bayes theorem, doesn't matter. So some people in a very layman's language consider this as the Bayes theorem. Some people talk about the conditional probability. Total rectangles can be done through permutations. Yeah, that's right. Total rectangles is not a consecutive selection, na, Rishabh? When I ask you total rectangles, why you need any consecutive selection, anything? Just select shortlist 2 parallel, 2 vertical lines and 2 horizontal lines. It's a lines concept. It is the lines concept. Total rectangles is the concept of lines. Now, what I taught you is not lines. This is not lines. When I spoke about the area, I didn't speak about lines. Clear, Rishabh? Total rectangles is the concept of lines. It is just the concept of lines. How many vertical lines? How many horizontal lines? Yeah, it is the concept of lines. That's it. Okay, and we spoke beyond that. I didn't speak about lines at all. Because this is kind of taken for granted. Lines we know. How to deal with lines we know. Okay, and I spoke the next level of that. That's what I did. Right? Okay, good. Good. Okay, in the same question, if you just want to understand this particular question, if I want to make it a probability question, right? Probability question, when a rectangle is selected at random, listen to this. I'm just going back to the previous question just to complete the Rishabh's point, right? He was saying that, okay, what if this question was when a rectangle is selected at random, what is the probability that on this grid, they gave the story saying that dimension is 1 centimeter, all that story is given. And now the question is presented when a rectangle is selected at random, what is the probability that it has an area of 12 centimeters square? It has an area of 12 centimeters square. Then you will find your answer. Your numerator, use 60, whatever the ordeal you went through, you go through all this ordeal to figure out that your numerator is 60. Denominator should be total number of rectangles. What should be the denominator? Total rectangles. It is the concept of lines. It is the concept of lines. Now, how many vertical lines I have? Vertical lines. Number of vertical lines are 9. Number of vertical lines are 9. I just need any 2 lines out of 9 vertical lines. When the grid is 8, when the columns are 8, number of lines are 9, right? There will be 9 lines. Similarly, how many horizontal lines are there? First horizontal, second horizontal. By the time you come to the last one, if there are 6 rows, then there will be 7 lines, and hence any 2 out of 7 lines is fine. It is the concept of lines. Total rectangles is the concept of lines, but when I want a particular area, it is no more a concept of lines. Comfortable? Clear? Not only Rishabh, everybody is clear about it, where the line is coming in the picture, but I was talking beyond the lines. I was talking about consecutive selections. Clear about this? If I just make a probability question, this is how you would have answered it. Okay? Yeah, that clarifies. Shall we go further? Right? Okay, we learned something. That is the consecutive selection is what we learned so far. If you ask me what was the concept I was discussing with this particular question, I was talking about being mindful about consecutive selections. I was talking about that. Okay, good. All right, let's go on to the conditional one. Conditional probability means a part of outcome will be given. First listen to me, after that you can read that question. In a conditional probability, a part of outcome will be given. Generally people read this, little bit of extension of this people read under Bayes theorem as well. It doesn't matter. So conditional probability, Bayes theorem, interchangeably you can call them. I don't mind it. Yeah, here we come. Now he says that look, their bag has 4 marbles. There is a small bag. Child has a small bag. It has 4 marbles. Now 2 marbles are drawn out at random, 2 marbles are picked at random, and they are found to be red. Okay, now you went there was a child's bag, you pulled out 2 marbles and you said both are red. Now you are curious. What is the curiosity? What is the probability that all are red? You got a doubt. Assume something like that. There was a bag which was kept there, small bag kept there, in which there were some 4 marbles, right? You understood there are 4 marbles. You touched it, you figured out that there are 4 marbles inside that, and you pulled out 2 marbles out of it, and then you realize that hey, both are red. Now the curiosity, what is the probability that all 4 can be red? Even before you pull out the remaining 2 to check, you got a curiosity. What is the probability that others also can be red? Okay, those who have done, I know that some of you have done 11th standard math out here. I will give a minute for you guys to think about this particular case. I'll give a minute. I will just pause for a minute. You think about it for a minute. Right, you think about it for a minute. Those who done 11th standard, if you remember something, at least recall. I am not saying that you should answer. To be fair to you, I should give time for you to recall. Otherwise, it will be unfair. Otherwise, it would be unfair. Part of outcome is given. 2 are already red. Curiosity is what is the probability that other 2 are also red, which means all are red. That's the curiosity. Conditional probability means part of outcome will be given to us. Okay, good thought. All right, now come back. I just wanted you to think. That's it. Don't worry. I'm not judging you. Nothing out there. I never judge anyone. That's not the idea here. I help as much as possible. That's my role out here. Okay, fair enough. Understand this. 3 cases are possible. What is the first case? 2 are red out of 4 marbles. Out of 4 marbles, 2 are red. That is possible. That case is possible. What is the second case? Second case are 3 can be red, which means after you see all 4 marbles in your hand, you might realize that, hey man, 3 are red out of 4 marbles. Out of 4 marbles, 3 are red. That can happen. What is the third case that is possible? Okay, third case possible is 4 are red out of 4 marbles. All 4 are red out of the given 4 marbles. On the face of it, these are the 3 things which are possible. You can't say that, no sir, there is another case, 1 can be red out of 4 marbles. out of 4 marbles. You may say that no, there is another case is also 0 are red out of 4 marbles. No, part of outcome has been already said. 2 marbles are red, already 2 are red. Therefore, I know that only 3 cases exist. That is the first point. That is the first point. What is the probability of the first case? What is the probability of case 1? The probability of case 1 is 1 by 3. Everything is equally likely. Everything is equally likely. There is nothing that, okay, it is not possible, that is not possible. Everything is equally likely. Either case 1 happens, or case 2 happens, or case 3 happens. I'm just telling you, what is the probability of case 2? That is also 1 by 3. If there are 3 cases, anything is equally likely. All right, now you can't say that no, there will be 4 reds for sure. No, it's a probability, man. Either 2 reds out of 4 marbles, or 3 reds out of 4 marbles, or all of them can be reds as well. That is on the face of it. Now hold on. Don't jump to conclusion. First part of this study is there are 3 cases. That is the first thing that should come into your mind. How important is that? That we will see it later. Whenever you are doing a conditional probability, first assess the number of cases. What all cases possible out here? Assessment of the cases. Fair enough. I did the assessment of cases. If required, write the probability of the cases. I wrote the probability of the cases. Good. We wrote the probability of the cases. Next thing. All right. Now then comes the another thing. What is the event here? What is the event here? Let me write it as event A. Let me write all it. There is an event. Something event happened. What is the event? Event is getting 2 red marbles. All right. What is the event A? I'm just giving a name here. Event A is drawing out. You already got 2 red marbles. All right. You got 2 red marbles. 2 red marbles out of 4 marbles. This is what occurred. This is the event which has already occurred. This is the event A. I'm giving a name to this particular event. What has occurred? You put the hand in the bag and you lifted 2 marbles. You check that both are red. This event has occurred. Event is what? You got 2 red marbles out of 4 marbles. All right. Okay. Now the point here is what? It is possible that these 2 red marbles, now listen to me very carefully. Event 1. I'm writing E1. What can be the event 1? Event 1 is you might have got these 2 red marbles out of 2 red marbles, because there were only 2 red marbles there and you are lucky that you got 2 out of 2 possible. There is another event inside this. In our event 2, I'm writing this. You might have got these 2 red marbles out of 3 red marbles. Out of 4 marbles, 3 can be red and you got 2 out of that possible. That also might have happened. There is another event which is possible that you got 2 red marbles. You got 2 red marbles out of 4 red marbles, because in the given 4 marbles, you've said that this is the case 1. What was this? This is related with the case 1. This is associated with case 2. Association I'm writing. When did I get 2 red marbles? This is associated with case 1. This is associated with case 2. This is associated with case 3. Now don't panic, guys. What is that, sir, you are trying to do so terrible? No, it's not terrible. While explaining, I have to explain. First question on conditional probability, I need to explain the way of thinking. After that, you don't have to think, call it now, so exhaustively. What I'm allowing you to do now is an exhaustive thinking. Sure, studies like that. When I have to teach you something, I have to take you exhaustively and then say that, hey, this is the consolidated version. This is what you kind of do there. Fair enough. Now look at this. Those who have done a little bit of math in the 11th standard, as a purist, you write something like this. Hey, probability of event 3 given that event A occurred. You may say that, sir, from where on earth you are writing this? Probability of event 3. What is event 3? 2 red out of 4 red. This is what you are looking at. Look at the question. What is the probability that all are red? All are red means what? 4 red. This is what you wanted. Conditional probability is always written as something in the numerator given divided by something in the denominator. How do you read that? Probability of event 3. That is probability of probability that all 4 are red given 2 are already red. Denominator is read as given that 2 are already red. That 2 are already red. That is how you kind of read this conditional probability. Okay. How do I express the result on this conditional probability? Guys, don't panic. This I am writing it for the purist perspective. From a purist perspective, what is the Bayes theorem? What is the conditional probability? If you were to recall like this. But when it comes to practical perspective, you don't have to write it so exhaustively. Don't panic about that. Don't panic about it. Let me write it here. From the purist perspective, let me first write it. Otherwise, those who are purist will blame me, thinking that, sir, you taught only half of the stuff. Yeah, let's write it here. Probability that it is event 3 given that event A occurred. What is event 3? Definition is here. What is event A? Definition is here. Please read those definitions to understand what is event 3, given that event A occurred. Now coming to the numerator. What I wanted in the numerator? Probability of finding event A out of event 3. This is my numerator, because assuming, alright, what is my numerator? Numerator is event 3. Out of event 3, event A has occurred. That is my numerator. What is my denominator? My denominator is event A might have occurred out of event 1, event A might have occurred out of event 2, event A might have occurred out of event 3 as well. Event A can be a function of, or event A might have occurred out of event 1, event A might have occurred out of event 2, event A might have occurred out of event 3 as well. Okay, now let me write it from the purist perspective. How do we write this particular proposition? You write this particular proposition like this. First you will write the numerator. I am writing the numerator here. Listen all of you carefully. Then we will come and write the answer. How to write the answer quickly, that perspective we will come to it. First let's write this part. So now first they will say that what is the probability of that C1 occurs, because out of C1 out of C3 E3 occurs. What is the probability that C3 occurs? 1 by 3. 1 by 3. Okay, now what is the probability that A occurred? A means event A occurred, given that it is the condition of E3, condition that it is E3. You write it like this. Okay, 4C2. What do you mean by 4C2? There were 4 red marbles, out of which I got two red marbles. Now denominator is 4C2. Hang on, all of you hang on till I finish this thought. All of you hang on here, hang on. It's not as cumbersome as it looks. The denominator, first case I'm writing the first case. First case, what is the probability of E1 happening? Probability of this happening. Case 3 should occur. Case 3 should occur for this. Alright, for E1, sorry, case 1 should occur. Case 1 is what? E1. E1 is related with case 1. Here, my friends, E1 is related with case 1. E1 is related with case 1, 1 by 3. Okay, case 1 occurred. Now, within this particular case, I am saying that event A occurred, that is 2C2. Why 2C2? There were only 2 red marbles and both you got luckily, but the reality is you could have got any of the 2 out of 4 marbles. You could have got any of the 2 out of 4 marbles plus. Now coming to the second portion, I am writing the second portion here, right? E2 should occur. E2 is a function of C2. What is the probability of C2? 1 by 3. What is the probability of C2? 1 by 3. Fair enough. We wrote that. Then what is the probability that A occurred in the event of C2? In the event of C2, there are 3 red marbles, out of which you got 2 red marbles. You write this as 3C2 divided by, in reality, you could have got any 2 marbles out of 4 red marbles plus. Now I am writing the last event here, which I have already written in the numerator and I explained it. I will repeat that, 1 by 3. So there are, event 3 is made up of 4 red marbles. You could have got 2 out of those 4 red marbles, which you write this as 4C2 divided by denominator. You would have got any 2 out of 4 as well, but all 4 were white. This is what you could have written. Now upon simplification, you realize that man beat case 1, case 2, case 3. Now observe all of you. You've been very patient so far. Now observe all of you. Case 1, case 2, case 3, anyway the probabilities were same. Case 1, case 2, case 3 probabilities were same. Therefore, even you wouldn't have written this, it doesn't matter. It doesn't matter. Denominators are always same. Why? Because you've drawn out 2 marbles out of 4 marbles. Because you have drawn 2 marbles out of 4 marbles. Therefore, these 4 C2s also doesn't matter. Technically, what matters? Technically, what matters in the numerator is 4C2. Alright, 4C2. Technically, that is what you would have written. The denominator becomes 2C2 because 2 white marbles were there and both you got. Or 3 white marbles were there, you pulled out 2 out of it. Or 4 white marbles were there and you pulled 2 out of this. This is what you kind of written there. 6 divided by 1 plus 3 plus 6. This is what you could have written. 6 divided by 10, and hence your answer becomes 2 divided by 5, which is the actual answer for this particular question. This is the story behind the conditional probability. I will do couple more questions based on this. Okay, so and then you become familiar about this. So come back to this lecture discussion. Please repeat this once again. Do this once again. Conditional probability is important for CAT, XAT and IIFT. It is important because once you are on the B school campus, conditional probability plays a very important role. All your data analytics is built on conditional probability. Yeah, normal probability also comes, but nobody appreciates if you answer a normal probability. You ask questions on the data sheet with respect to condition and you get the answers as conditional probability. That is what professors like. They will give a data sheet. They will ask you only create that question. If you create a question based on conditional probability, they will love it. If you create some dummy question based on that, they will say that your analytic skills are not that great. Okay, yeah, therefore CAT, XAT and IIFT generally ask once in a while here and there about the conditional probability, which can also be studied under the base rule. Looks like long story. I said a long story. You may have to rewind this after this lecture, but try to study this. All right, try to study this. It is not as cumbersome as it looks. I will do few more examples, right, with your permission. Is it so far good? Kind of understood? Kind of understood? Say yes. I spoke at length for 15 minutes to explain conditional probability. I know it could have been boring for some of you, but you kind of understood. At least gives a confirmation, some solace to me. Yeah, something we understood kind of. This is the full story. You want to read further story, Google it and read. But it's good to know because CAT asked this question. I'm not doing anything which is not asked in CAT. I don't do things for intellectual curiosity. We will do something productive. We'll do something productive. Don't worry, Preet, you will learn. As you practice, you will do. Yeah, Rishabh, kind of. Good comment. Yes. Bit exhausting as well. Yeah, because 15 minutes, I think I spoke at length. Yup. Yeah, okay, good. There is no choice in the sense like, no, when you go on to the B schools, you got to do all this, my friends. You got to do all this. There is no choice. If you want to get good credits there, you don't have a choice. And who is creating these questions? You guys will create in the B school because they will give a case. They will give a data with some 30,000 rows. And who has to ask questions on those 30,000 rows? You guys have to ask. That is what they test. If you don't know how to ask the right question, no marks will come. Data is available in the net. Now, who has to ask the questions on the data? You guys have to ask the questions on the data, right? That's what is expected in the B school. Today, we are solving questions. There, you ask a question and then answer the question. You do both. You do both on the B school campus. That is what you will be doing there. Okay, let's take a look at this particular question. Yeah, let's finish this concept, okay? Because if we wind up now, I know that it's already past 11. If we wind up, then it will be incomplete. Let's do at least 2 more examples. Let's do some examples so that we will be at least getting into the groove and then further you can proceed from there. Yeah, take a look at this question. I will just give a minute here. Think about this question. Your answer or not doesn't matter. Think about this question for a minute. It's important to think. Yeah, just think about this. Put your thoughts behind it. Don't relax. Hang on. There is a change. All right, now this should be 4. This is a typo error. If 4 turned up 3 times, what is the probability that 4 turned up exactly 4 times? That's a typo error. It's not 3, it's 4. A dice is rolled a total of 5 times. If the number 4 turned up at least 3 times, conditional probability, we know that it has already come 3 times. What is the probability that number 4 would have turned up exactly 4 times? exactly 4 times. Okay, do it with me. Do it with me. Let's do it together. Where the conditional probability is given, partial output is known. It has come at least 3 times. He's saying that, which means minimum 3 times it has already come. At least 3 can be 3, or it can be 4, or it can be 5, right? Number 4 has turned up either 3 times, or it would have come 4 times, or it would have come 5 times. Or it would have come 5 times. That's a possibility. That's the meaning of the word at least 3 times. Number 4 coming at least 3 times means this. Okay, what is that I want? I want exactly 4 times. I want exactly 4 times. What is that? Probability that number 4 appeared. Number 4 appeared 4 times. That's in my numerator. Okay, number 4 you keep it in mind. So number 4 appeared 4 times. Number 4 appeared 4 times. 40 I will write. What is in the denominator? In the denominator, it might have appeared only 3 times. That is possible. Or it might have appeared 4 times. Or it might have appeared 5 times. That is the denominator. Reality is what? Because when it appeared at least 3 times means what? It might have appeared 3 times, or 4 times, or 5 times. Out of which, what is the probability that it appeared exactly 4 times? Okay. Firstly, what is probability of getting a 4? Probability of getting a 4 is 1 by 6. What is probability of not getting a 4? Therefore, what is probability of not getting a 4? Probability of not getting a 4 is 5 by 6. We should be ready with these two parameters. Fair enough. Now author is saying that, hey, when it is rolled, which means one after the other, first time, second time, third time, like this 5 times when you rolled. Okay, now he is saying that 5 times like this, my friends. Roll 1, roll 2. The third time you rolled, fourth time you rolled, fifth time you rolled, and sixth time you rolled. Possible that 4 came here, 4 came here, 4 came here, and 4 came here. Here something else came, maybe 5 came, maybe I'll let know here 3 came, something like this. That's a possibility. But the point is in which 4 positions 4 came out of these 5 rolls. Sorry, it is 5 rolls, right? Yeah, it is 5 rolls. In which 4 positions 4 came, that I don't know. I'll let in which 4 positions it came, I don't know. Now, this is what we learned yesterday under binomial probability. Write this. 5C4, I'm writing this one, this part I'm writing. This is written as 5C4. You rolled 5 times. 4 times the 4 would have come. Probability of getting the 4 is 1 by 6. 1 by 6 raised to power 4. And then 5 by 6 raised to power 1. This is how your numerator looks like. All right. Denominator, what is probability of getting 3? Probability of getting it 3 times. You say that 5C3 because 4 would have come 3 times. Which 3 positions? I don't know out of 5 rolls. Therefore, I write this as 5C3, right? 5C3, and then I will write this as 1 by 6 raised to power 3, and the remaining 5 by 6 raised to power 2. Where did we learn this? Writing like this we learned yesterday. I'm putting the conditional probability along with binomial distribution of probability. I'm putting them together. Okay, now next one. I'll let 4 times. So this we will write it as 5C4. We already wrote this. 1 by 6 raised to power 4, 5 by 6 raised to power 1. And finally, the last one, when you write all this 5 out of this, you can write this as 5C5. Then you write 1 by 6 raised to power 5 and 5 by 6 raised to power 0. This is what the answer for this particular question looks like. All denominators gets cancelled because all of them are 6 power 5s. They will get cancelled. You can simplify this and you will get some answer which would be represented in the exam. You understood this? Everybody clear about this question? How binomial distribution is getting squeezed with conditional probability? Comfortable? Everybody comfortable on this? Got this? You may have to go back to these videos and listen a little bit. Now these are all CAT questions only. CAT type, CAT, IIFT, ZAT types. Getting this? Everybody getting this? Why don't you confirm? Or are you already left the meeting? Sir, very tired. I am tired or you are tired? Somebody is tired and you left. Okay, Rishabh is there, Vibha is there, Asim is there, Sumit is there. Guys, are you all learning something? I know it might have gone a little deeper today. And sometimes beyond 11 o'clock makes it appear much more deeper. But are you learning something? You're getting hang of this kind of? Getting hang of this? Of course, in the B school, this is what you guys will do. Especially on the data and the statistics chapter, statistics course. And statistics is a mandatory course. And those who want to get into analytics, you don't have a choice in the matter. These are the kind of presentations you'll be doing. Right? Yeah. Yeah, Preet, you may have to go through it once again. No doubt, no doubt. You may have to go through it. No, you may have to go through it. Okay, one last question. One last question. This came in CAT also. This came in IIFT also. Yeah, one last question. Now, this is much easier. Much easier than what we were doing. Answer this. Try and answer this. much easier than what we were doing. And we will close with this. And we'll see what we'll do tomorrow. We'll go to that and then we'll close. Yeah, all right. Listen, guys, listen. Okay, let us take yourself as an example. For example, I'm taking Preet as an example. Let's assume. Okay, I'll take Preet as an example. Preet has a dice at his place, and I don't know. I'm here at my workstation, and Preet is at his workstation. So he rolled a dice. He rolled a dice, and he said that, okay, it is 6. He rolled a dice. I don't know. I don't know. So you can take yourself as an example. You rolled it, and I am on this particular side. I am trying to write the answer. What can be the probability that Preet has actually got the 6? That is the question. What is the probability that he got the 6? Preet has rolled a dice and he said that, sir, I got 6. Alright, he mentioned in the chat, I got 6. Now, I know only one thing about the Preet, that Preet speaks truth 4 out of 5 times. Right? Preet, don't feel bad that, sir, I speak truth all the time. It's okay. It's okay. Just you are an example. Don't get offended that, hey, this is not a nice example. Why my name 4 out of 5 times, which means do I lie one time? I'm just not questioning any of this. Just as an example, right? So just as an example, I'm taking your name. Don't feel bad. So because it might not be a nice example, but somehow before thinking, I just jumped into this. Yeah, any which ways. Okay. So I know only one thing about Preet or anybody. I know that, okay, it is 4 out of 5 times he speaks the truth. Okay, probability of speaking the truth is 4 by 5, 80%. Therefore, probability of not speaking the truth, hiding the truth, is 1 out of 5. Probability of hiding the truth is 1 out of 5. Okay, yeah. All right, the next part. All right, next part. It might have, next part is what? He got the 6. He got the 6 and it is true. Now look at, listen to this statement very carefully, my friend. All of you listen to this very carefully. If he claimed, what did he claim? He is claiming that I got 6. Preet is claiming that he got 6 and none of us have any idea. He has just texted this in the live chat saying that, sir, I got 6. That's it. All we know about Preet is, okay, he speaks 4 out of 5 times the truth. That's it. Okay, therefore 2 things. How do you write it? Exhaustive. You may think that, hey, Preet has spoken the truth. All right, Preet has spoken the truth. Therefore, it is 6. Because he claimed it to be 6. If you think that he spoke the truth, then the outcome is 6. Then it implies that the outcome is 6 or if you think that Preet did not speak the truth, he hid the truth, which means he lied or he hid the truth, implies that he got anything other than 6, which means he got 1, 2, 3, 4 or 5, but not 6. These are the 2 speculations. You think that if you agree that your Preet might have spoken the truth, then the outcome is 6, because he only said that. He shouted. He put that in the chat. He said that it is 6. Okay, good. Or if you think that Preet might not have spoken the truth, then the outcome would be any of this. Yeah, this is all the probability I should write. What is the denominator? Therefore, denominator is this. Preet has spoken the truth. I am writing the answer here. Preet spoken the truth means 4 by 5. And the outcome is 6. Outcome is 6 means 1 by 6. Because on the dice there is only 1 6. 1 by 6 or means plus. Preet did not speak the truth. Preet not speaking the truth means 1 by 5. You are doubting him. Okay, therefore the outcome has to be 1 to 5 out of 6. Therefore you are saying that it is 5 by 6. The dice has shown the other 5 numbers other than 6. Therefore it is 5 by 6. This is your exhaustive case. This is your denominator. What is your numerator? Numerator has to be this, because that is what author is asking. What is the probability that it is 6? Probability that it is 6 means Preet should speak the truth. Preet should speak the truth. Fair enough. Therefore, write the numerator. Your numerator is Preet has spoken the truth and the outcome is 6. Denominator is Preet has spoken the truth and it is 6, or Preet has not spoken the truth, and it is not 6. 6 dash I am writing, it is not 6. We are ready with the denominator already. This is our denominator. I just have to plug the numerator. Numerator is nothing but this particular case. So upon simplification, you get the result as 4 divided by, you get the result as 4 divided by 9. That becomes your answer. Are you all with me? Clear about this? Do you all get this? Did you all get this? You can simplify. You can write these numbers. Upon simplification, it simply becomes 4 by 9. It becomes 4 by 9. That's answer. That's answer to this question. Comfortable, my friends? Did you learn something about these conditional probabilities and things? Rishav, it is not possible. No, if he gets a 6, how did he lie, man? If it is 6, then he spoke the truth. It is not possible that he claimed 6 and it's a lie. No. He claimed it to be 6. If it is true, then it is 6. If it is false, it is other than 6, right? It should be other than 6. No, that is what we are saying. If it is not 6, then it is this. Then it is 1, 2, 3, 4, 5. Then it's 1, 2, 3, 4, 5. Clear? All these are night 11 o'clock problems. At 11 o'clock, mind thinks little crazy at times. Happens with me also. Happens with others also. Depends. Unless people are used to work too well in the night. Yeah. Okay. Nazia, you are asking that are these mutual? Yeah, they are mutual. They are mutual. Because it should be either 6 or not 6. Absolutely. It is mutual. You are right. You are right. It is mutual. Mutually exclusive. Because either it should be 6 or not 6. That's right. In this case, it is right. All right. That kind of brings us to the end of discussion. Did you all learn something, friends? Everybody? Can you claim, was it interesting? Or was this conditional probability in between became very boring? So please go back to this lecture and listen once again. It is important for your future also, not just the present. This thing, what I did today, is important for your future as well. When you get into the B schools, especially on the statistics, you do a lot of this. You do a lot of this. On that day, you will remember, yeah, that guy Belvi was talking about this. Today, I am doing it at night 3 o'clock. That's what you will remember while you are writing your assignments. Right, when you're doing your assignments at B schools, trust me, you will remember me on this particular probability. Quick announcements before I do. Or you have this doubt, alright, now so doubt, ask a doubt kind of an issue, ask a doubt of feature. That's a new feature that's available on the Unacademy app. That's available on the Unacademy app. A lot of you get the content doubts, etc. This is one way that you can get onto, but you have to refresh the app. Go there, and what you do is just refresh your app, get the new features. This is one of the features. Ask a doubt is one of the features, and if you have some of the doubts not getting addressed, you can use this facility. Now, how to quickly use this facility? Try it out. So it's a pretty simple. The using the facility is very, very simple. All you got to do is just go on to this particular app. Just get onto the app, and you have the feature coming right on the top, doubts and solutions. Doubts and solution. Click on that, take a screenshot and plug that screenshot and put that, whether it is from QA, DI and LRA. It's a self-navigation. You are all very smart. All right, just that. All right, now this feature comes on your dashboard right on the top. Just click that and send that particular question. You will sure get the answer as soon as it could. All right, pretty fast you will get this. And yes, these are some of the free mocks. I encourage you to write some of these particular free mocks, and there is an analysis of this particular free mocks, one of which I was trying to attempt to make it today. Today in the evening around 8ish, I made an attempt to brief on this particular mock, first mock, which happened on 17th. Sure, we'll make an effort to bring, along with the video solutions, all that stuff, we will also try and bring some effective analysis as we progress. So the mocks are coming on 24th, 31st and 7th, 3 consecutive Sundays. That is 24th is this coming Sunday. You can try and take a look at this. Take a look at this. Okay, what we do is we will reconvene tomorrow at 10 p.m. Probably we will start geometry. We will do a little bit of geometry because this is something which we didn't do at all. That's tomorrow on the Unacademy YouTube channel, on the Unacademy Cat YouTube. So tomorrow at 10 p.m. we will do geometry. We will kind of start with the geometry. Those who have the plus subscription, join me tomorrow maybe around 7ish. All right, around 7ish we are continuing our study on logarithms. You can join me out there. Yeah, that's pretty much about today. And if you have liked this particular lecture, despite being little boring, already being denser, doesn't matter, you can like it. If you liked it, you like it, and then you can share it. Yeah, so that's pretty much about today's lecture. All right, I will see you guys maybe in the next lecture. Okay, Nazia is saying that consecutive concept was good. Thank you. Good. Nice. All right, guys, that's pretty much any comments you can leave it here, and those who are listening maybe after the live lecture, you can put the comments in the comment section. The non-live comment section is always there. You can put it there and I will see it and I will try to respond if it is there. Otherwise, you can come on to the Telegram and you can just put your short doubts, etc. All right, so I will close it. If there is no questions from your end, I will close it at this stage. Good night. I will see you guys tomorrow evening. Bye till then.